Today we're going to start a series of lessons on how we can use several different theorems and postulates to prove that two triangles are congruent. The lesson today is by using the side-side-side congruence and the side-angle-side congruence. So basically what the side-side-side congruence says is that if three sides of one congruent if three sides of one triangle are congruent to three sides of a second triangle, then the triangles are congruent. Well, obviously that makes sense because we know if the two triangles are the same size, then they're congruent. That's what congruence means. But if we compare the sides, then we don't, if it says that if all the sides are the same, then the angles are going to be the same as well. So that's where that comes into play. So the side-side-side congruence says that if all the sides are congruent to the other triangle, then the two triangles are congruent. The side-angle-side congruence postulate says that if two sides and the angle that's between the two sides are congruent, then between the two triangles, then the two triangles are congruent. Okay? So if we have this side right here, okay, if we have this side over here is congruent to this side here, and then this side here, side 2 is congruent if BC is congruent to FE, and the angle B is between AB and BC, and angle E is between ED and EF. That means that these two triangles are congruent by side angle side. All right? So sometimes we need to use the distance formula to determine whether the side lengths are going to be the same. All right, especially if we're talking about triangles that are drawn in a coordinate plane. So just as a reminder, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. All right. So that's the distance formula. We talked about that earlier this year. So let's just compare. It says use the distance formula to determine whether the triangle ABC is congruent to triangle KLM. Well, so let's go. Let's see if AB is congruent to KL. Okay, AB is negative 3, 3, negative 1, 3. KL is 1, 4, and 3, 4. Okay, so let's find the length of AB. All right, so x2 minus x1, so we're going to do square root of negative 3 minus negative 1 squared plus 3 minus 3 squared. All right, so when we do that, we end up with square root of negative 3 minus negative 1, that's change. Negative 3 plus 1 is negative 2 squared plus 3 minus 3 is 0 squared. All right, negative 2 squared is 4, and square root of 4 is 2. All right, using the blue for KL. All right, so we're going to use the distance formula. x2 minus x1 squared plus y2 minus y1 squared. Okay, So we got, I'm going to do 3 minus 1. So square root of 3 minus 1 squared plus 4 minus 4 squared. All right, 3 minus 1 is 2 squared plus 4 minus 4 is 0 squared. And 2 squared is 4, which is 2. All right, so KL and AB are congruent. So AB is congruent to KL. All right, so that's the one set. Now this is a little bit work intensive to do it using the distance formula, but we got to work our way through it. All right, so um, one of the ways that we can possibly do that is by using our graphing calculator. Okay, rather than doing everything by hand. All right, so if I pull up my graphing calculator, all right, and so the next one that we're going to look at is um, BC and LM. All right, we're going to do BC, and LM. All right, so BC is -1, 3, and 3, -1. LM is 3, 4, and 1, 6. All right, so we just plug it in, clear it out. All right, so we're going to do square root of, okay, we got a parentheses, so we got to do another parenthesis, whoops, square root of, we got to do another parentheses because that square root deals with the whole thing. Otherwise, because basically what we have to do here is we have to make sure that we have square roots under that enclose all of these. Okay. Otherwise, the calculator doesn't know that we're taking the square root of everything. It thinks we're just taking the square root of this over here, of the x's. So we have to put parentheses around everything. All right. So square root of parentheses. Now we subtract the x values for, we're doing BC. So we say -1 minus -3, close it, square it, plus parentheses, subtract your y values. I started with a -1 here. So that means I need to start with the 3. So that would be 3 minus 1, close parentheses, square it. And then we got to do the closing parentheses and then hit enter. And we end up with square root of 2.82849. Okay, so this would be, if we did this -1 minus -3, that'd be 2 squared plus 2 squared, which would be square root of 8. Okay, and so and it doesn't really matter what let's just do the LM, okay? So we do the square root, put the extra parentheses in, all right? 3 minus 1, close parentheses and square it, plus parentheses 4 minus 6, close parentheses, square it, closing parentheses, and hit enter. And you notice that we end up with exactly the same number. So we can say that BC is congruent to LM. Okay, and then the very last one that we're gonna end up doing is AC and KM. Okay, so we have AC and KM. All right, get a calculator back. All right, AC. Now it's important to notice here that the sides A, B, and KL are congruent to each other, but they're not congruent to BC and LM. All right, so BC and LM are two separate sides. So let's do AC. All right, so AC is negative 3, 3 and negative 3, 1. KM is 1, 4 and 1, 6. All right, so we're going to do square root of negative 3 minus negative 3. So negative 3 minus negative 3, close it, square it, plus 3 minus 1, close it and square it, close the square root, and we had an error. Okay, so let's see where there is. Okay, square root negative 3 minus negative 3 squared plus, I didn't put a parentheses there. All right, and put the parentheses, then hit enter, and we end up with 2. All right, so AC is 2. The length of AC is 2. Okay, so KM. All right, second square root. Right, K is 1 minus 1, close, square it, plus parentheses 4 minus 6, close parentheses, and square it, and then close the square root and hit enter, and we see that is the length of that side is 2 as well. So AC is congruent to KM. All right. So all this work has gone into basically just showing that all three sides are congruent. So now we can say ABC, triangle ABC is congruent to KLM by side, side, side. Okay? That's all that amounts to right there. All right? All right. Once again, we can do the same thing here. All right. Okay, so use our formula, use our calculator, and we're going to see if ABC and if AB and KL are congruent. So we're going to move this over here. AB are second square root. So we have -4 minus -4, closing parentheses, plus parentheses -2 minus 1, square it. Forgot to square this. I forgot to square this over here. Okay. And hit the insert and hit squared. Come back down to the bottom here and close the parentheses for that square root. We end up that AB is equal to 3. All right. And so let's say KL. All right. So second square root, put the parentheses for the x values. 0 minus 0 is just simply 0 squared. Okay. And plus -2 minus 1, parentheses, -2 minus 1, close parentheses, square it, and then close the parentheses for the square root, and so KL is equal to 3, okay? So we know that AB and KL are congruent, all right? So let's do BC and LM, all right? BC is, okay, I'm going to clear this out first. Second square root, BC is -4 minus 1, -4 minus -1, close the parentheses, square it, plus parentheses for my y's, and we end up with 1 minus -1, close the parentheses, square it, and close the parentheses for the square root, and end up with 3.6. Okay, so let's do LM. Okay, so do square root, parentheses for the x's. We have 0 minus 4, close parentheses, square it, plus parentheses 1 minus 1, close parentheses, square it, and then close the parentheses for the square root, hit enter. And we notice here that the two sides are not the same here. So we said that BC is equal to 3.6 and so on. Okay, and LM, we noticed that LM is Let's just double check to make sure we didn't make any errors. But we have LM. Okay, so BC, we have -4 minus -1 plus 1 minus -1. Okay, so that's what we got there. We end up with 3.60555125. LM 0 minus 4 squared plus 1 minus 1 squared. And we had said that the length of LM is 4. So that is not congruent. Okay, so we can say that these triangles are not congruent because we can already see that two of the sides are not the same length. Okay, two of the corresponding sides. So that's, as soon as we find one of them that is not the same length, we don't have to even worry about the third one. All right, next one says, which postulate can be used to prove the triangles are congruent? Well, what are we given? What are we comparing? We're comparing sides, side 1, side 2, and side 3 are all congruent, so we could use side, 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 because that's what we're given in both triangles. All right. Here, we're given which postulate can be used to prove the triangles are congruent. Okay. Well, we're given that this side and this side are congruent. We're given that according to the reflexive property, this line down the middle is congruent to itself. All right. And uh, and that is the only thing that we can that we can use, because we don't know anything about the angles or anything else. So we don't have any way of saying whether they're congruent or not. Okay, so we're going to say that they're not congruent, that the two triangles are not congruent, because we can't use any of the postulates to tell us that. Okay? Which postulate can be used to prove the triangles are congruent? Well, once again, we have a side, two sides. So we have two sides and we have an angle. Okay? But here again, there's an issue in that the angle is not between the two sides. If we're wanting to use side angle side, we would want to use this angle to be shown. Well, we're not given that angle, so we cannot say that it's side angle side, so we cannot show that those two triangles are congruent. Okay? All right. Which postulate can be used to prove the triangles are congruent? Well, you have side, two sides, and then these angles here are vertical angles, and so they're congruent. So we can show that these are side angle side, because the two sides and the angle that's between the two sides. That's how you can prove that those two triangles are congruent. Okay, so that does it for this lesson, and make sure that you ask questions. If you don't understand something, make sure that you write down that distance formula. Use your calculators to help you find the distances of the lines, the lengths of the sides of the triangles. And we'll talk to y'all later on.